Good morning. Myself Sheikh Abdul Qayyum. Today I am going to discuss about zero force member. Now it is one parts of the structural analysis of truss structure, and in the previous few videos we have already gone through method of joints and method of section. So if you have not seen those video, please kindly go through those video first and then come to this lecture. And in this lecture today we will discuss only about zero force member. We will solve one particular examples, uh, so that you can understand how to solve for different members, when they are subjected to zero force. Now, what is zero force member actually is? Zero force member actually, in our truss structure or any kind of structural analysis problem, we can see that in some of the cases there is some members within our truss structure that is actually supporting no forces. Actually there is, if we analyze the whole truss or whole member, then we can find that that particular member or of that truss is subjected to zero force. There is no force at all. But even though we are providing those support, that may be due to that fact that uh, in the near future there may be some sorts of loads that may come, and due to that there may be some additional force that may induce in that particular member. So for the safety purpose, sometimes we provide those kinds of those kinds of members which in the existing situation, existing load condition, uh, is subjected to zero force. Now there may be another situation. Suppose at the time of fabrication of one particular truss member, maybe due to the stability purpose. Suppose in order to make the system stable, sometimes we provide some additional members which we remove after the casting of the complete truss. So that may be due to this purpose also. Sometimes we provide some additional members, those which actually support no loads. At the same time, in some structural analysis problem, we may see that one particular stress is unstable. So in order to provide the stability of that particular members, sometimes we provide extra members, and those members actually do not support any kind of loads. So those are the zero force member. And why we provide zero force member, I have already discussed it now. And depending on that, before going to start the structural analysis of one particular truss structure, it is very important to identify whether that particular member is which particular member is subjected to zero force. Because if we can identify those members where there is no force at all, then our solution will become very easy, and we can efficiently solve those problems in the structural analysis of truss problems. Now, truss analysis using method of joints is greatly simplified if one is able to first determine those members that support no loading. So it is very important, even before we start for solving, we it is very important to identify those structure where there is no load at all. This zero force member may be necessary for the stability of the truss during construction and to provide support if the applied loading is changed. Sometimes there is a possibility that the applied loading that may vary due to the some changes in loading situation, which maybe there is, if there is any probability that this loading situation may change. So due to that, for additional safety, we sometimes provide those zero force member. The zero force members of a truss can generally be determined by inspection of the joints, and they occur in two cases. So, in order to find out the zero force member, we need not to go for mathematical calculations. Just by simple inspection and by simple concept, using some basic concept, we can find out just by looking at the joints itself that whether that particular member is zero force member or not. Now, as I have told, in two cases there may arise some conditions of, there may be some zero force member. So in the first case, the two members at joint C are connected together at a right angle. You can see in this particular figure as well, the two members at joint C, this is joint C, and the two members at joint C are connected together at a right angle. That means the internal angle between these two members is 90 degree. So in this case, and you can see at C there is no other external loads. So as there is no other external load, so if we draw the free body diagram of this particular point, then what will happen? uh, the free body diagram will look like, let me draw it. The free body diagram will look like this. One member force will be there. One member force will be in this direction, and another member force will be in this direction. Now what happens if we apply the equations of equilibrium, that is sum of fx equals to 0. So from here you can see that there is no other horizontal forces other than these forces. This is force BC, FBC. If we call it as member force BC, then there is no other horizontal forces other than this one. So obviously, in order to maintain equilibrium, this force must be 0, and that is the concept of zero force member. So for the equilibrium to exist, this BC, this member BC will be subjected to no force at all. So member BC is a zero force member. At the same time, if we apply the equations of equilibrium, that is sum of Fy equals to 0, then what will happen? There is no other vertical force other than this member force CD. So ultimately, in order to maintain equilibrium, this member force CD must be 0, and that's why we can say that member CD is also a zero force member. So just to we have solved these two problem. We have identified that member BC and member CD is a zero force member, without even going for the mathematical calculation and without even going for any other derivation. Just by looking at the joint and visually understanding the situation, we can say that member BC and member CD is subjected to zero force. Now the zero force may occur in case of this situation as well, where zero force member also occur at joint D, at joints having a geometry as joint D. As you can see, if we show you that this angle is 90 degree. So as this angle is 90 degree, and you can see there is at point at joint D, there is no external loading, there is no external force at all. So as there is no external force, what will happen if we draw the free body diagram of this particular joint? It will be like this. Sorry. If we draw the free body diagram of joint D, then what will happen actually? There will be one force in this direction, there will be another member force in this direction, there will be another member force in this direction, and the internal angle between the member force DF and the member CDE is 90 degree. So as this internal angle is 90 degree, and if we uh, apply the equations of equilibrium, and if we sum up for all the forces that is parallel to DF, then we will end up with only one forces, that is DF. There is no other forces uh, um, other than DF in this particular direction. So ultimately, if we sum them up, then what will happen? In order to maintain equilibrium, as there is no other forces, this there is no because there is no other forces to equilibrate this member force DF. So in order to maintain equilibrium, this member force DF must be equal to 0, because there is this force is suppose if it is even 1 Newton, then also the structure will be unstable, and there will be no equilibrium within this structure. The structure will fail because at the joint D there is no other force to overcome, to resist this member force DF. So in order to maintain equilibrium, this member force DF must be zero. So this is the second case where we can say that member force DF is a zero force member. Now, as you can see here as well, zero force member also occur in this occur at joints having the geometry as joint D, and no external load acts on the joint. So as there is no external load acting in the joint, so this is very important. Because there is no external load acting on this joint, that's why in that particular situation member DF is becoming zero. So a force summation in the y direction which is perpendicular to the two collinear member requires that FDF equals to zero. Now, using this result, FCF FCF. So if we can see that is also now one before going to that part, I want to say one thing, that you can see the geometry of joint D and joint B is very similar. There is no basic difference between these particular two. But in case of BG, it will not be a zero force member. Why? Question. Because if we draw the free body diagram of this particular side, and we can see there is one member force in this direction, there will be another member force acting in this direction, there will be another member force which is at an angle 90 degree with the previous two member force, that is AB and BC. But here we can see that if this angle is theta, this internal angle between PB load PB and this BC is if the internal angle is theta, then we can distribute this load in two direction, that is one in the horizontal direction and another in the vertical direction. And if we do so, then what will happen? If we distribute this load component, then there will be one vertical component at this particular point, and there will be another horizontal component at this joint. So there is some loadings, that is load P sine theta. If this internal angle is theta, then there will be P sine theta to balance the load in BG. Sorry. So there is this will be P sine theta, and which will balance the forces in BG, member force BG. So due to if we say in different way, that due to this force P, the vertical component will be P sine theta, and in order to balance that P sine theta, there must be some sorts of force within this member BG, because in order that in order for the equilibrium to hold good, this there must be some sort of force within this BG, and this should be equal and in opposite direction of the forces that is coming out from the P, that is the component of P, that is P sine theta. So this member force will be equal to P sine theta. So this is not a zero force member. So from this we can easily say that if there is no external load and at the same time, although the geometrical shape is very similar for joint B and joint D, but at joint D there is no external load, and that's why there is no load that can balance the member force. That's why this member force is becoming zero. Now, if we come to the joint F, then what will happen? And if we draw the free body diagram of joint F, then what will happen? We can see that uh, FDF will be one member force, and that we have already computed that this is zero. Now there is FE force FE in acting in the horizontal direction, the positive x direction. We have FG that is acting in the negative x direction, and we have force CF that is acting at an angle theta with the horizontal direction. Now, if we distribute FCF, in two particular component, one in the vertical direction and another one in the horizontal direction. Then what will happen if we distribute this? Then we can see that there will be one component acting in this direction, vertical direction. Will be another component of FCF acting in the horizontal direction. So this will be the vertical component of FCF will be FCF sin theta, and the horizontal component of FCF will be FCF cos theta. So now if we as we have distributed this FCF force in two particular component, one in the vertical direction and another in the horizontal direction, now we can see from the free body diagram, existing free body diagram, as if df is 0. So if we sum up all the vertical forces, then what will happen? We are left with only single forces, that is FCF sin theta, and there is no other force other than this FCF sin theta in the vertical direction. So in order to maintain the equilibrium, in order to equilibrium, for the equilibrium to hold good, this FCF sin theta must be equal to 0, because there is no other force at all, and at joint F there is no external force as well, that external force which may balance this FCF sin theta. So due to this reason, as there is only one particular force, that is FCF sin theta, so in order for the equilibrium to maintain, FCF sin theta should be equals to 0. And as you can see, sin theta is 0 only when theta is 0. And you can see from the, it is evident from the figure that theta is not 0 here. So in this particular case, as theta is not 0, so the value of sin theta is not 0. So if the value of sin theta is not 0, and FCF sin theta, the value of FCF sin theta is 0, then FCF must be 0. So force FCF must be 0 in order for the equilibrium to exist. So in from this as well, from analyzing this joint as well, we can say, even before the calculations to start, we can say that CF member for CF is a zero force member. So this is another important case when you can find a zero force member. And at this particular case, you can see that this member for CF is becoming 0 depending on the situation, and because it is becoming 0 because FDF is 0. If DF is not 0, then if FDF is non-zero, then FCF should not be 0, because there will be some additional force other than FCF. So that force may equilibrate this FCF sin theta force. So as in this particular case, FDF is 0, that's why FCF is 0. And if we look at joint G, the same configuration, but in this case the member force CG is not 0 because the member force BG is not 0. As the member force BG is not 0, so there will be some contribution of member force BG in the vertical direction, and that will be resisted by the contribution of the member force GC, uh, the component of member force GC that is acting in the vertical direction. So this is very important. Same geometry, but as there is some loads at joint P, so the member force BG is non-zero and member force CG is non-zero. But for as at the joint D, as there is no other external load, so member force DF is becoming 0 and member force CF is becoming 0. So in this particular figure, we have two zero force member, that is CF and DF. Now we will go for one particular simple example, and we will find out the number of zero force member, what are the zero force members are in this particular figure. So using method of joint, indicate all members of the truss that have zero force member. But in this particular figure, before going to the method of joint, we will find out what are the zero force member just by visual observation the of the joints without going for the mathematical calculation. Now, if we start with joint D, uh, sorry, let me start with joint H. If we start with joint H, then what we can see, and if we draw the free body diagram of this particular joint H, then we can see that uh, as this angle, this member BH is at an angle 90 degree with the AF. So uh, if we apply the equilibrium equations, that is sum of all the vertical forces equals to 0, taking the direction BH as the vertical, then what will happen? Uh, uh, we can easily see that there is no other forces in the vertical direction. Or if we sum up all the if sum of Fy equals to 0, that is sum of all the forces in y direction equals to 0, and if we take this direction as y direction, the direction of BH as y direction, then we can say see that there is no other force other than this member force. So obviously, in order to fulfill equilibrium, this member force BH should be equals to 0. So this member BH is a zero force member. So we have already determined this one. This is a zero force member. Now, if we come at joint D, then what will happen? If we come at joint D, we can, and if we draw the free body diagram of joint D, then what will happen? We can see, as you can see from this particular figure as well, that at joint D, there is two force. One is FDC, that is inclined at an angle theta with the horizontal, and FDE, that is in the acting in the x direction. Now, if we distribute this FDC into particular component, then what will happen? If we distribute this FDC into particular component, then what will happen? We will get that the horizontal component of FDC will be FDC sine theta, and vertical component will be FDC sine theta. Let me draw this one. One will be horizontal component of FDC, and another will be vertical component of FDC. So horizontal component is FDC sine theta, cos theta, and vertical component is FDC sine theta. Now, if we apply sum of Fy equals to 0 in this particular figure, then what will happen? As there is no other force other than FDC sine theta in vertical direction, in y direction, so ultimately, in order to maintain equilibrium, this FDC sine theta should be equals to 0. And if FDC sine theta is 0, and we can see from the value of theta that sine theta is a non-zero, then obviously FDC will be 0. And if FDC is 0, then there will be no contribution of FDC in the horizontal direction as well. So this will also be 0. So because FDC is a zero force member in this particular figure. So we from this we have found out that FDC is a zero force member. Now, if we go for again, if we analyze this one, as we can see that we can see as if DC is 0, as if DC is 0, so there will be no contribution of this FDC in both vertical and horizontal direction. And if there is no contribution of FDC in vertical and horizontal direction, then this if the free body diagram of joint D is left with only one force, that is FDE, that is acting in the horizontal direction. So there is no other force in the horizontal direction other than this FD. So in order to maintain the equilibrium, if we apply sum of fx equals to 0, that is sum of all the horizontal force in the x direction or in the horizontal direction equals to 0, then ultimately fde will come out to be a zero force member. So from the, just by visual observation, we can also see that that fde is also a zero force member. So we have what we have analyzed so far. We have seen this is a zero force member, this is a zero force member, and this is also a zero force member. So we have already seen that three member is a zero force member, fdc, and we have already written here fdc, fde, and we have written fbh. These three we have written. So let me make a tick mark: FDC, FDE, and FBH. So this three is a zero force member, and we have already have seen how this is coming. Now, if we look at joint E, then what will happen? Look at this joint and draw the free body diagram of this. So this is the free body diagram of joint E. So what happened? There is the external load P acting in the vertical downward direction, that is negative y-axis. There is one horizontal forces acting in the x direction, and we have computed that this member force is a zero force member, so we have shown it like zero. There is one member force acting, that is a member force ef, that is acting in the negative x direction, and there is one vertical force fce, member force fce, that is acting in the vertical direction. Now, if we apply sum of fx equals to 0, that is sum of all the horizontal force equals to 0, then we can see that fef plus fef minus 0 equals to 0. So ultimately fef is also coming out to be 0, because this member force ed, f member force ed is a zero force member, because fef minus fde equals to 0, or fef minus fed equals to 0, and as fed equals to 0, so fef will be equals to a 0, and from this we can find out that this member force ef is also a zero force member. So we have already, now we have found out this is also a zero force member. So ef is also a zero force member. Now if we look at joint G, then what will happen? Look at just go for the free body diagram of joint D. Draw the free body diagram of joint D. What will happen? There is one member force FGF that is acting in the negative x direction. We are considering this member force as compressive in nature. Now, as this is a roller support at joint G, there is a roller support. So there will be only vertical reaction. In this case, as roller, the direction of roller is like this, so there will be only horizontal reaction due to this roller support. So that if we call that gx is the reaction forces due to the roller support. So gx is the reaction force due in the x direction, and there is another member force fga in the acting in the vertical direction. Now this is the total free body diagram of joint G. Now if we apply sum of all the forces in the vertical direction equals to 0, that is sum of fy equals to 0, then what will happen? Then we are left with only one force in the vertical direction, that is fga. So there is no other force other than fga in the vertical direction. So ultimately this fga, this force fga should be equals to 0 in order to maintain the equilibrium. So from this analysis also, from this visual observation also, we can say that fga, that is member for ga, is a zero force member. So from there we can find out that fga is also a zero force member. So these are the 5 member that is a zero force member actually. So from as we can see in this truss, 1 2 3 4 5 6 7, 8, 9, 10, 11, 12. Out of 12 member, we already have found out that 5 member are zero force member, even before going to the mathematical calculations. So as we found out that these 5 members are zero force member, so it is now it has become very easier for the problem to be solved, because we already have solved for almost half of the members. So that's why it is very important to identify what are the zero force members even before going to the mathematical calculations, just by going to the visual observation of the joints. So if you have any doubt, you can comment it in the below, and I will try to clear you down. Thank you.